Welcome to an algebra tutorial video learning about single variable inequalities. We're talking about how to solve these inequalities, doing things to both sides. We're trying to find what is that solution set? What are all the possible numbers that make our inequality true? So we're going to talk specifically about multiplication and division as solving these inequalities out. And we do really similar stuff to what we do with equations. We do the same thing to both sides to get the inequality by itself. If there's division, we multiply, that's the inverse, or vice versa. However, with inequalities, there's one thing we got to be really careful about. Whenever we multiply or divide on both sides by a negative number, whenever that's our problem-solving strategy to help figure this thing out, as soon as we do a negative number, multiply or divide, we need to reverse the inequality. Because essentially what we're doing is we're taking what was positive and turning it into a negative number. We're taking what was negative and turning it into positive. It's polarizing the whole thing around. And since less than typically goes to the left and greater than goes to the right, but we're making all those positive negatives different, it ends up that we need to adjust our inequality to match what should work. So we'll talk about that here. We'll go through a couple examples, and I think you'll get an idea. Okay, let's start talking. Let's do 5x has to be greater than 29. We want to know, well, what are all the possible numbers for x that when I multiply it by 5, I end up with a number bigger than 29. Let's solve that out. So I have x is multiplying by 5. That's a multiplication problem there. So if I want to do the inverse operation, if I want to get x by itself, I need to do the opposite of multiplying by 5. I need to divide both sides by 5. So 5 divided by 5, those end up dividing each other out, leaving just 1 times x. 5 divided by 5 is 1. And 1 times anything is just the same thing. So 1 times x just leaves x. And we have our variable isolated. I love it. But if I divide the left side by 5, if I make it smaller or divide it into 5, I have to divide the right side by 5 as well to keep the integrity of everything. So 29 divided by 5, 5 goes into 29 5 times, which is 25, but then there's 4 left over, so a remainder of 4. 5 4/5, also I can rewrite that as 5.8. I can rewrite that as a decimal if I want to. Now let's think about what we did. We divided both sides by a positive number 5, and I'm only concerned really if I divide it by a negative number. So I don't have to reverse the symbol, so I can keep it down, and I can see that x is a number greater than 5.8. Well, let's check it out. Let's do a check here. So if x is greater than 5.8, that means I should be able to put 6 in, and it should be a solution. 6 is bigger than 5.8. All right, so let's see. Does 5 times 6, is that actually greater than 29? Well, 5 times 6 is 30, and 30 is greater than 29, so it checks out. I picked a number that was greater than 5.8 just to double check that it works, and it did. So there's my solution set. X has to be some number greater than 5.8. Okay, there's one good example. Let's take a look at another one here. Now I've got negative 3/4 times x, and I want to know, well, what are all the numbers x that make it less than or equal to 9/2? Do some fractions in there for you guys. I know you can't get enough fractions. Let's solve this thing out. Draw my line down the middle there and then inequality so I can remember to do things to both sides. This is x times negative 3/4. So in this case, if I want to turn that into 1, the inverse operation would be to multiply it by negative 4/3. Multiply it by the reciprocal. The negative times negative is going to cancel it out, leaving a positive number. 4 times 3 leaves 12 on the top. 3 times 4 means 12 on the bottom. So I end up with 12 divided by 12 times x. 12 divided by 12 is just 1, leaving just x. So I'm good. We've just simplified the left side. But if I multiply the left side by negative 4/3, I need to multiply the right side by negative 4/3 as well. It's keeping things balanced, which is the same stuff we did when we did with solving equations. All right, so let's do some fractions here. Multiplying fractions, 9 times 4 gives me negative 36 on the top. 2 times 3 gives me 6 on the bottom. It's very fortunate because negative 36 divided by 6 just ends up being negative 6. It divides evenly. All right, now here's where we have to pause a second. So what do? We multiplied both sides, but we multiplied by a negative number. So now I have to add in that little bit that makes solving inequalities different than equations, is that when I multiply or divide both sides by a negative number, which I did right here and right here, I have to reverse the inequality. So no longer is it less than or equal to. I'm going to spin that thing around, and it becomes x is greater than or equal to. Did you catch that? That's reversing the inequality. It's still equal to, but instead of the arrow pointing one way, it points the other way. All right, but let's just check this out. Maybe you don't believe me. Maybe you think I'm doing some weird wishy-washy math stuff. So let's check it out. So according to this, if I pick a number greater than or equal to negative 6 and plug it in for x, that should make the inequality true. So I'm going to pick a nice one like 1. So let's check. If I make x 1, that's greater than or equal to negative 6, and let's see if that makes my inequality true. So does negative 3/4 times 1, is that less than or equal to 9/2? Well, negative 3/4 times 1 is just negative 3/4, right? It doesn't change a thing. So negative 3/4 is less than or equal to 9/2. And here I can say, yeah, well, this is a negative number. It's going to be less than a positive number because it's on the left of it on the number line. The other thing I can do to make it a little more tangible would maybe to turn it into decimals. Negative 3/4 is the same as negative 0.75. Use my calculator to do that. 9/2 is the same as 4.5. And then you can clearly see, yes, 4.5 is greater than or equal to negative 0.75. So this does check out. And we tested out. This is a good way to, if you do have to reverse the inequality, if you get a little fearful of like, do I need to reverse it? Do I not need to reverse it? I'm not sure. I'm confused. Just do a quick check. If you solved it out and I forgot to flip it, and so I checked and I put a number that didn't work out, then I might say, oh, whoops, what did I forget to do? It's not working out. I'm not checking my solution. It's not working. Maybe it could be just something as simple as you forgot to reverse the inequality. But there you go. There's a couple examples. One example where we did not need to reverse it, and one example where we multiplied both sides by a negative number, and we did have to reverse the inequality to get a true statement. All right, hopefully that's a helpful introduction for solving inequalities and being very careful about our negative numbers.